You might be asking yourself, why does he want to talk about the importance of chemical nomenclature? Why doesn't he just tell us what chemical nomenclature is? Well, it's the naming system for chemical compounds. But the reason I'm talking about the importance of it is because every year I teach this. And actually, I teach it to AP and dual credit students who were taught it in their regular first year or pre-AP chemistry, and they didn't take it seriously. And it makes them terribly performing students. It makes them, the ones who don't take this seriously, don't do well for the rest of the year. And this is at least one part of the reason why. So it's very important. And why is it important? Because it allows us to communicate about the compounds that we're talking about. The rules of chemical naming are to chemistry what phonics and vocabulary are to language. When you learn the language you speak, you learn the alphabet. When you learn the written part, you learn the alphabet, then you learn phonics so that you could take letters and make words that match the sound you heard. And then you made those words into sentences eventually. And sentences can carry a large amount of meaning. And then if you were able to convert between the symbols, the letters, and their phonics that are associated with them, and the word that they made, and the thought that conveyed, then you could pick up thoughts from people who had died thousands of years ago, or who live on the other side of the earth, because you could read what they had written well, or the translation of what they'd written. And so in chemistry, we're dealing with element symbols, so you have to know what symbol stands for what element. Then we compose those into compounds, and there's a kind of a formula that goes there. It's not just any old list of the element for that symbol and the element for that symbol, but it's the symbol for that element, the symbol for the other element. But it comes in a particular ratio. And then after you've got those correct, you can make them into chemical equations, or sometimes you're given chemical equations, and you have to know all the details of the naming, how the name corresponds to the formula for the compound in order to get the chemical equation right, which is going to affect the math of what you're going to be solving later. So let me show you an example. Suppose this was just a description of a chemical equation that was in part of a problem for you. It says the second part in the process of chloridizing roasting of antimony sulfide involves reaction of solid antimony 3 oxide with solid sodium chloride disulfur gas and oxygen gas to produce solid sodium sulfate and gaseous antimony 3 chloride. Well, that's a lot of words, but it has a lot of meaning. So here's what that would look like in formula form. The second part in the process of chloridizing roasting of antimony 3 sulfide is antimony 3 oxide plus sodium chloride solid plus gaseous disulfur and plus oxygen gas. And those things reacting together make sodium sulfate in the solid form, and also the gaseous form of antimony 3 chloride. Notice I haven't even balanced this equation, but I could not have balanced it correctly if I didn't have the right formulas from the names. And so if I can't balance this equation correctly, then I can't do any math on it to say, when I use so many grams of this plus so many grams of that plus so many liters of this and this, how many grams of that will I get and how many liters of that will I get? You can't even work the problem at all. You're dead at the starting line if you can't write the right formula from the name. So the purpose of naming rules is to unambiguously assign a name for a particular single compound. That means when we say this name, we mean this particular compound with this particular formula. Just like you learned in you learned about the binomial nomenclature developed by Carolus Linnaeus for biology, for the organisms in the world, to unambiguously identify each organism so scientists could communicate, or researchers or students could communicate clearly and only know that they were talking about the same thing when they used the same name. Okay, here are some examples that show the significance of naming. There are two different compounds composed of carbon and oxygen, so you can't just say carbon oxide, because there is a carbon monoxide form, CO, and carbon dioxide form, CO2. Carbon monoxide, it turns out, is very different in its properties. It is lethal to humans and many air-breathing organisms, it's lethal to them in really low concentrations. Whereas carbon dioxide is something you blow out of your mouth every time you exhale, and it's probably in a concentration coming out of your mouth of something like 40,000 parts per million, which is around 100 times more concentrated than the atmospheric concentration of CO2. There are at least 3 different chlorides. Here's a different example. There are at least 3 different chlorides of chromium, so you can't just say chromium chloride. Chromium could have a +2 charge, chromium could have a +3 charge, chromium could have a +4 charge, and if so, it's going to have, what the chromium chloride we're talking about is going to have a different formula. Chromium 2 chloride is going to be CrCl2, chromium 3 chloride is going to be CrCl3, chromium 4 chloride is going to have 4 chlorides associated with that chromium 4. Here's another example. For instance, there's a pretty big difference between ethanol and ethanal. Here's ethanol with an O, and here's ethanal with an A. And here's the formula for ethanol, which is the alcohol in alcoholic beverages and also the alcohol that's an additive in some of our gasoline at some gas stations. But ethanol is a different chemical compound with different properties. It's used in some disinfectants. It's used in the process of making certain pharmaceuticals. And it's also used, for instance, in the industrial process of making certain resins. So these are quite different compounds. So the small difference of saying ethanol instead of ethanal is really representing a big difference chemically speaking. And it would affect balancing the equation and all this business, okay? So who makes the rules? Well, there's an official body, an official organization called the International Union of Pure and Applied Chemists. Sometimes we just call it IUPAC or IUPAC. They're the people that make the most official rules, and their rules have superseded rules that were used, maybe 50 or 100 years ago. So what types of compounds should we know how to name? Well, here are the four categories you need if you're in AP and dual credit chemistry. You're going to need to know how to name ionic compounds, which are also known as salts. You're going to need to know how to name acids and covalent compounds, and also organic compounds. That'll probably be new for all of you. Now, if you're in first year chemistry or pre-AP chemistry, then you don't need to know about the organic compounds. We're going to learn the basics of that in AP and dual credit, but not in pre-AP. So that's what you need to know. This is very important. Don't think that you can ignore it.